Good morning, students. In our previous lecture, we discussed about various classification of polymer. Since we know whenever any reactant converts into product, then there is a proper pathway for this formation. And this proper pathway is known as the mechanism. So today we will discuss the mechanism of polymerization. As we all know, in order to make a polymer, there are two ways, either by adding the monomers or by condensation. So first, we discuss about the mechanism of addition polymerization. As we all know, in addition polymerization, the monomer units will simply combine to each other and will give a large number of polymer chain. And this is known as chain growth polymerization. Now, how this process occurs? It can undergo by three mechanisms: free radical polymerization, cationic polymerization, and anionic polymerization. But in class 12th, we only discuss about this free radical polymerization. Students, we are very much familiar with this mechanism as we already studied about this in 11th class also. We know free radical polymerization or free radical mechanism occurs in three steps. First step is the chain initiation, second one is the propagation, and last is the termination. So let's see how chain initiation occurs. For this, we took a compound, that is benzoyl peroxide, and we broke this bond homolytically, and we are getting our this C6H5 radical as initiator. Now this initiator will attach with this ethene molecule, because here we are doing the polymerization of polythene. So we took the monomer ethene, and this free radical now join with this monomer unit. We will break this bond homolytically, and this initiator get attached with this CH2, and our bigger radical is thus formed. Now we discuss about the second step, that is the propagation. In propagation, this radical will attach with another molecule, and this chain will continue till. As you see, this radical is combining with this ethene molecule, and the chain is going on, and we are getting a bigger radical. Now the last step is the chain termination. That is, we have to stop this chain so as to get our polymer. This termination can be done by two ways. First is by combination of free radical. Out of these growing radical chains, we will consider any two chains like this, and we will join these two radical, and thus we will get our polymer of desired length. Second one is by disproportionation. For this, again we consider any two growing radical chain, and in this process, student pay attention. From this CH2, I write this CH2 like as CH and H. We broke this CH2 homolytically. Thus, a radical is generated over CH radical, and this H radical comes out. This H radical will join with this CH2 radical, and thus one polymer is obtained here, and the CH radical which is here will make bond with this radical, thus we get another this polymer. This is how the addition polymerization occur. Now our next topic is preparation of some addition polymer. Students, pay attention. In this topic, what we have to do, we will discuss various type of polymer. And in this topic, we will do, or what we have to do mainly, you have to learn the names of monomers, structures of monomer and polymer, and their any two uses. So firstly is our polythene. As the name suggests, monomer is ethene, and it is used in order to make the squeeze bottles, toys, flexible pipes, etc. As we all know, polythene are of two types, low density and high density. In order to make the high density polythene, monomer will be the same, that is the CH2 double bond CH2, but some extra condition we have to apply, and this condition is we will use the catalyst such as triethyl aluminium and titanium tetrachloride. Very much important, it comes under 1 mark question also, and this is also known as Ziegler-Natta Catalyst. I'll show you the structure. This is triethyl aluminium and titanium tetrachloride. This is known as our Ziegler-Natta Catalyst. So while doing the polymerization by using the monomer ethene, we will put this catalyst over here and we will get the high density polythene. Again, the uses in order to make the buckets, dustbin, etc. Next example is our Teflon. For the Teflon, monomer used is this one, and the structure of polymer is this one, and it is mainly used to make the non-stick utensils. Very much important, students. The coating due to which the utensils have the property of non-stickiness is just because of this Teflon. Next is our polyacrylonitrile, in short form or in abbreviated form known as PAN, polyacrylonitrile, or also known as Orlo. Okay, as the name suggests, monomer is acrylonitrile. What is acrylonitrile? This is the structure of acrylonitrile. As we all know, the acrylic acid also, acrylic acid is our CH2 double bond CH and COOH. We will substitute this acidic group with this nitrile and we are getting the acrylonitrile. And the structure of polymer is this one, and it is used to make clothes, carpets, blankets, etc. So this all about the addition polymerization and their example. Next category is our condensation polymer. As we all know, in this type of polymerization, two different monomer will combine with the elimination of small molecule. We will not discuss their mechanism, only the mechanism was of addition polymerization, but the main thing is that this polymer is also known as step growth polymerization. Why known as step growth? Because in this process the polymer is formed in a stepwise manner, as there is a loss of molecule and after that a polymer is formed. That's why this is known as step growth polymerization. Again, in this topic what we will do, we will discuss various type of condensation polymer. We will learn their monomers, their structure and their any to use. So first category is polyamide. In this topic we will discuss the various example and we will put those example in a specific category. Mane the linkage, the bond specifically formed will be renowned as its main classification. The first one is polyamide. As we all know, amide linkages are C double bond O NH. And in this category, first example is nylon 6,6. Nylon. Students, nylon comprises two words, ny plus lon. Ny means New York and lon means London. This was first originated from the New York and London. That's why this is known as nylon. As we all know, we already studied about this in our previous topics. Nylon 6,6 monomers are adipic acid and hexamethylene diamine. As you see, this is the adipic acid and hexamethylene diamine, and the structure of polymer is this one. By losing the water molecule, we are getting this polymer, and there is this amide linkage. That's why we put this under the category of polyamide. Next is our nylon 610. We already done. Monomers are sebacic acid and hexamethylene diamine. The uses are, it is used to make carpet, textile fibers, in order to make the elastic hosiery, etc. Next is our nylon 6 or Purlone. Important one. The monomer used here is Caprolactam. Students, please pay attention to its structure. Caprolactam is, this is a cyclic structure in which total 6 carbons will be there. 1, 2, 3, 4, 5 and 6. So this is the caprolactam, and when you hydrolyze this, this bond will break and the chain will opens by NH2, these 5CH2, and this is the COH. As you see, both acidic and basic group are present here, so also known as Zwitter ion. Zwitter ion are basically those in which both acidic and basic group are present. So I can write it as this base will obstruct this H and will become NH3 positive and COO negative. This is known as aminocaproic acid also. On polymerization, by repeating these units several times, water will be out and we will get our desired polymer, that is the nylon 6. It is used to make tire cords, fabrics and ropes, etc. Next categories are polyester. As you see, the linkage will be formed here will be our ester. And the examples are tyrrolene or the dacaron. For this, the monomer used are ethylene glycol and terephthalic acid. Water will be out and we will getting our ester linkage. As you see, example uses are highly inert, so used in making with mix with cotton